Okay, Wildcats, doing it. 4.3, relating inverses of transformations. Recall that the inverse of an exponential function is a logarithmic function. Let's explore how the transformation of an exponential function and its inverse are related. 1. Consider the functions f of x equals 2 to the x and g of x equals f inverse of x, or log base 2 of x. The graphs of f of x and g of x are provided. Graph the transformation on f of x, describe the transformation performed on each, then graph the inverse of the transform function. Find, describe, and label the graph of the inverse of the transform function as a transformation on g of x. All right, let's take a look at the next page. A, f of x plus 4. The transformation on f of x is translated to left 4 units. The transformation on g of x is translated down 4 units. Go ahead and write that down and complete the graphs. B, f of x plus 5. The transformation on f of x is translated up 5 units. The transformation on g of x is translated right 5 units. All right, go ahead and write transformations down and complete the graphs. All right. C, f of x minus 3 plus 6. Transformation on f of x. f of x is translated right 3 units and up 6 units. The transformation on g of x is translated right 6 units and up 3 units. All right, go ahead and write down the transformations and complete the graphs. D, f of x plus 1 plus 1. Transformations on f of x. f of x is translated left 1 unit, up 1 unit. Transformations on g of x. g of x is translated left 1 unit and up 1 unit. Go ahead and complete the graphs and write the transformation down. All right, let's take a look at the next page. Two, generalize the effects of transformations on f of x and its inverse function, f inverse of x. Complete the table to organize your results. Go ahead and read over the table and complete that. All right, let's take a look at 3. Consider the function y equals f of x and the transform function g of x. Write an equation for g inverse of x in terms of f inverse of x. A, when g of x equals f of x minus 1, g inverse of x is f inverse of x plus 1. When g of x equals f of x minus 2, g inverse of x is f inverse of x plus 2. C, when g of x equals f of x plus 5, g inverse of x is f inverse of x minus 5. D, when g of x equals f x minus 4 plus 3, g inverse of x is f of inverse of x minus 3 plus 4. Let's take a look at the next page. The function f of x equals 2 to the x and its inverse function f inverse of x equals log base 2 of x are shown in the table. Four, complete each table, write the inverse of the transform function in terms of f inverse of x, and identify the effects of the transformation on the inverse. All right, so the first point is negative 1 comma 3 times 1 half, which is equal to 3 divided by 2. The next point is 0 comma 3 times 1, which is 3. And the next point is 1 comma 3 times 2, which is 6. Now, when you do the inverse, the points switch. So this becomes 3 divided by 2, negative 1. This becomes 3 comma 0, and this becomes 6 comma 1. The transformation on f of x is a vertical stretch by 3 units. The effect on the inverse is a horizontal stretch by 3 units. Let's take a look at B. Okay, so the first point is negative 1 comma 1 half times 1 half, which is 1/4. Next point is 0 comma 1 half times 1, which is 1 half. And the next point is 1 comma 1 half times 2, which is 1. Again, the inverse, you switch the points. So this becomes 1/4 comma negative 1, 1 half comma 0, and 1, comma 1. The transformation on f of x is a vertical compression by 1/2 units. The effect on the inverse is a horizontal compression by 2 units. Let's take a look at the next page. C. The first point is 4 times -1, which is -4, comma 1/2. The next point is 4, comma 0, which is 0, comma 1. And the next point is 4, comma 1, which is 4, comma 2. Again, inverse, you switch the point. So this is 1/2, comma -4, 1, comma 0, 2, comma 4. The transformation on f of x is a horizontal stretch by 4 units. The effect on the inverse is a vertical stretch by 4 units. D. First point is 1 divided by 2, which is 1 divided by 2, comma 1/2. Next point is 0 divided by 2, which is 0, comma 1. And the next point is -1 divided by 2, which is -1, 2, comma 2. Again, with the inverse, you switch the point. So this is 1/2, comma 1/2, 1, comma 0, 2, comma -1/2. Transformation on f of x is a horizontal compression by 1/2 units. The effect on the inverse is a vertical compression by 1/2 units. 5. How does a vertical dilation on a function affect its inverse? A vertical stretch on a function will produce a horizontal stretch on the inverse. A vertical compression on a function will produce a horizontal compression on the inverse. 6. How does a horizontal dilation on a function affect its inverse? A horizontal stretch on a function will produce a vertical stretch on the inverse. A horizontal compression on a function will produce a vertical compression on its inverse. Let's take a look at the next page. 7. Given the function f of x, write the equation for the inverse function f inverse of x. Then graph the inverse function. Okay, so first step is we change f of x to y. So y equals 2 times 3 to the x. And then switch x and y. So x equals 2 times 3 to the y. Now we divide both sides by 2. 2 divided by 2 is 1. You're left with x divided by 2 equals 3 to the y. And then the last step is we take log base 2 of both sides. Oh, I'm sorry, log base 3 of both sides. Okay, now the log base 3 of 3 cancels each other, so you're left with log base 3 of x divided by 2 equals y. So f inverse of x is equal to log base 3 of x divided by 2. All right, let's go ahead and graph that using Desmos. So we're going to go to functions. We want the log with the base. So this is a base of 3 of x divided by 2. So we're looking for a good point here. 2 comma 0 is good, and we see that the asymptote is at x equals 0, and that's close enough to 6 comma 1. So we can use 2 0 and 6 1. All right, go ahead and finish up 7a. Let's take a look at b. Okay. So for the inverse, first we change f of x to y. So y equals log base 4 of x divided by 2. Next step is switch x and y. So x equals log base 4 of x divided by 2. We're going to raise both sides by the base of 4. So then we have 4 to the x. 4 raised to log base 4 cancels equals x divided by 2. We can cross multiply, so 1 times x, oh, I'm sorry, this should be y. That's a common mistake that happens, so look out for that. Switch x and y. Make sure that you write y, not x twice. Now we cross multiply. 1 times y is y equals 2 times 4 to the x. Okay, so the f inverse of x is 2 times 4 to the x. All right, let's go ahead and graph that using Desmos. All right, we need some good points. This looks like a good point here. And 0.1/2 or 0.54 will have to work. So, and then we see it, we have a horizontal asymptote at y equals 0. All right, go ahead and finish up B. Let's take a look at C. All right, so first step is change f of x to y. So y equals -5 to the x power. Switch x and y. X equals -5 to the x. And again, I did this on purpose to kind of reemphasize the mistake. This is a common mistake. Students tend to put x's for both, but remember you're switching x and y. So this should be y. Okay. Now we need to divide both sides by -1. X divided by -1 is -x. -5 divided by -1 is a +5 to the y. And then the last step, we need to take log base 5 of both sides. Log base 5 of 5 cancels. You get log base 5 of -x equals y. All right, let's go ahead and graph that. Oh, almost forgot. Let me write down here. So f inverse of x is log base 5 of -x. Okay, so we're going to go to functions, scroll almost to the bottom, and then you might scroll up. Log base 5 of -x. Look for a good point. -1, 0 looks good. And -6, it's close enough to 1 that we can use that, okay? Oh, let's double check where the asymptote is. It's at 0. There we go. All right, go ahead and finish up C. Let's take a look at the next page. Talk to talk. The student works 1A, 1B, 1C, 1D, 1E, and 1F. All right, let's take a look at the next page. The student works 2A and 2B. student works 1, 2, 3, 4, 1A, 1B, 2A, 2B, and 4A. All right, let's take a look at the next page. The student works 2A, 2B, 2C, 1A, 1B, 2, 3A, 3B, 3C, and 4. All right. Go and start working on your assignment and have a wonderful Wildcat day.